Good afternoon, folks. Now, I have discussion B for you, and we're discussing why women face higher risk of MS and what this new study adds. What the article is really saying. Why women face higher MS risk, and what the new study adds. The page lays out a simple narrative. Women develop multiple sclerosis far more often than men, and a new very early stage study may help explain part of that imbalance. Women make up the vast majority of MS. The article starts with the scale of the disparity of the 2.9 million people living with MS worldwide. About 3/4 are women. This gap has been known for years, but the biological reasons behind it are still not fully understood. A new study looked directly at women's cerebral spinal fluid. Researchers at the University of Colorado Medical Campus examined cerebral spinal fluid CSF from a very small group of women, 6 participants, to look for biological differences linked to MS. Even though the sample is tiny, the findings point toward meaningful patterns. What they found, they identified over 100 proteins in the CSF that were either higher or lower in women with MS compared to women of the same age without MS. These proteins are involved in different cellular processes. By mapping each protein to the cell it affects, researchers can start to see which biological pathways differ in women with MS. Why this matters: sex differences shape many brain diseases. The article emphasizes that MS is not the only neurological condition with a sex imbalance. Alzheimer's and MS are more common in women. Parkinson's is more common in men. The researchers argue that understanding these sex-based biological differences is key to uncovering the mechanisms that drive disease and potentially to designing better treatments. What this discovery could mean. The study is preliminary, but it offers new direction. These protein differences may help explain why women's immune systems respond differently, making them more vulnerable to MS. They could also point toward new therapeutic targets tailored to female biology, and they help build a clearer picture of how MS progresses in women, which has been understudied. The article frames this as a starting point, not a breakthrough, but a clue that could reshape how researchers think about MS risks and treatments. The big takeaway. The page's core message is women's higher MS risk may be tied to distinct protein patterns in their cerebral spinal fluid, patterns that reveal sex-specific mechanisms of the disease. Understanding understanding those mechanisms could eventually lead to more precise, more effective treatments for women. Women face a much higher risk of multiple sclerosis, largely because of biological sex differences in the immune system and brain, and the new research is beginning to pinpoint the mechanisms behind the gap. What the new discovery shows. A recent study from the University of Colorado Medical Campus analyzed cerebral spinal fluid from women with MS and found over 100 proteins that differed significantly compared to women without MS. These proteins reveal two major patterns: higher levels of immune-related proteins, especially those tied to microglia and macrophages, the brain's immune cells. This suggests heightened immune activation in women with MS. Lower levels of proteins involved in neuron repair and neurogenesis, indicating that nerve repair processes may be more impaired in women with MS. Together, these findings help explain why MS may progress differently and more frequently in women. Why women are more vulnerable to MS. Across multiple studies, several biological factors converge. X chromosome linked to immune activation. Women have two X chromosomes, and some genes on the X chromosome escape the usual silencing process, meaning women produce higher levels of certain immune activating proteins. One of these genes, KDM6A, has been shown to drive inflammation in the microglia. When researchers detected this gene in female mice, MS-like symptoms improved dramatically, but not in males. Multiple sclerosis, news today, UCLA Health. This suggests women have a baseline immune system primed for stronger inflammatory responses, which can increase MS susceptibility. Hormonal influences. Estrogen normally helps regulate inflammation during periods of hormonal fluctuation, such as the 30s and 40s, when MS diagnosis is peak. This balance may shift, making women more vulnerable. Immune system differences overall. Women's immune systems tend to be more reactive, which is helpful for fighting infections, but increases the risk of autoimmune diseases like MS. What this means for future treatment. These discoveries open new possibilities. Protein signatures in CF and CSF could become biomarkers to track disease activity or personalized treatment. Targeting X-linked genes like KDM6A may lead to sex-specific therapies. Existing drugs such as metformin are being explored for their ability to dial down inflammation in female brains. When women face MS, when women face a higher risk MS risk because of sex-specific immune biology. Here's a clear page-grounded explanation of the headline: Why Women's Brains Face Higher Risks. Scientists pinpoint X chromosome gene behind MS and Alzheimer's, based directly on the content of the UCLA Medical or UCLA Health article you're viewing. Women's higher risk of MS and Alzheimer's may come from a specific gene on the X chromosome that overactivates inflammation in the female brain. The study identifies that gene shows it shows how it behaves differently in females and even pinpoints to a possible treatment. The discovery an X linked gene that drives inflammation. The article explains that UCLA researchers identified a gene on the X chromosome, KDM6A, drives inflammation in microglia, the brain's immune cells. Because women have two X chromosomes, they receive a double dose of this inflammation promoting gene, while men have only one. Inflammation in microglia is a major contributor to age-related brain changes, Alzheimer's disease, multiple sclerosis. This is the biological foundation for the sex difference the headline refers to. What the researchers did using a mouse model for MS, scientists deactivated the KDM6A gene in microglia, observed that MS-like disease and brain pathology improved dramatically in female mice. Noted that the effect was minimal in males, consistent with females having more to block because of two X chromosomes. This strongly suggests that female biology amplifies the inflammatory pathway. A potential treatment already exists. The team also used metformin, a common diabetes drug, to knock down the protein produced by KDM6A. Metformin shifted microglia from an activated inflammatory state to a resting state in female mice. Because the effect was far weaker in males, the study suggests women may respond differently to metformin-based treatments for neural inflammatory diseases. Why this matters for women's brain health. The article connects this gene to several real world patterns. Women get MS and Alzheimer's 2 to 3 times more often than men. This long observed disparity is highlighted directly in the article. 2/3 of women experience brain fog during menopause. The study's lead author notes this and ties it to the same inflammatory pathway. Menopause removes estrogen's protective effect. Estrogen normally center balances X-linked inflammation. When estrogen drops during menopause, the X-driven inflammatory effects are unleashed in the brain. This helps explain why estrogen examinations often intensify during midlife for women. The big picture. Putting the page's content together. Women's higher risk for MS, Alzheimer's, and menopause-related brain fog may stem from an X chromosome gene, KDM6A, that overactivates inflammation in the female brain. Blocking this gene genetically or with drugs, likely metformin, dramatically reduces disease in female mice, pointing toward sex-specific treatments. The article frames this as a major step toward understanding why women's brains age differently and how to protect them. Okay, guys, that is B for you. I will see everybody later tonight for shows. For now, Gator Wellness. Take care, folks.